Good afternoon and welcome to today's International Space Station Expedition 35 status briefing. With us today are Joel Montalbano, the International Space Station Deputy Program Manager, Ed Van Cise, our Spacewalk Flight Director from today's EVA, and Jacqueline Kagi, the Lead EVA Officer for today's Spacewalk. We'll start off with some opening remarks from each of the participants and then we'll move on to your questions. Joel?
Well, good afternoon. Thank you again for joining us. As you know, we had a pretty good challenge for our on-orbit crew and our ground teams, and they did a fantastic job. You saw today Chris and Tom going outside. The overall plan today was to go out to the site that we saw the leaking ammonia, the snowflakes that you've seen so much on TV. Take a look, see if you see any obvious signs of damage, see if you see just something that doesn't look right. The crew did that. They did not see anything. We then, per the plan, had them go ahead and take out the pump and flow control assembly, inspect it once again for damage, look where it sat in the truss to see if they saw, again, any obvious signs, something that just didn't look right. They didn't. We had them, per the plan, install the spare. They did that. We then had the crew back off, and we had the mission control team power up the systems. The crew watched and looked for any obvious signs of leaks and did not see anything. So I will tell you that we're happy. We're very happy. We didn't see any obvious sign of a leak, but it's going to take some time. It'll take some weeks for us to look at the system, evaluate the system, and make sure we did indeed stop the leak. But again, today, no obvious signs, so we're very happy with that. I'll let Ed and Jackie give you some details, but I will tell you with this behind us, we're going to be focusing on the Soyuz landing. Tomorrow afternoon will be the change of command ceremony. Chris Hadfield will hand over to Pavel Vinogradov approximately 2:30 p.m. local Houston time, and that'll support a Soyuz landing with Roman Romanenko, Chris Hadfield, Tom Marshburn, Monday evening Houston time, approximately 9:30 p.m. So with that, I'll hand that over to Ed.
Thanks, Joel. It was just 2 days ago that the slight leak that we were observing in this thermal control system took a change to where it was a pretty dramatic leak. And it was at that time where the program thought it would be best to take advantage of having Chris Cassidy and Tom Marshburn on board together to try to get out to the site and see what we could see and replace any hardware we could. So they challenged us to try to get a spacewalk put together in just 2 days' time to go do what we did today. Obviously, we spun up what we call a Team 4 effort, which is pretty much bringing everybody to the table that we can to help pull together every piece of information that we need to be able to go execute something like this. We're also very fortunate in the way the vehicle was configured and the way that the crew was prepared. A lot of the configurations that are required in order to go do a spacewalk were already in place, and with the crew that we had, they'd actually been out to this work site together on a previous shuttle mission, so a lot of things worked in our favor to be able to pull this spacewalk together. Joel covered the objectives that we had for today. The highest priority was to get out to the site and just lay eyes on the situation and see if we could see anything obvious as to what had changed that the leak rate had increased. But in the fall, we had reconfigured the system to change which radiator we were using to cool the ammonia system. And given the fact that we had a change in the leak, the only real option that we had was to try replacing the pump package, and if that also didn't fix the problem, then it was somewhere in the plumbing. So besides going out and inspecting, we took on the challenge to attempt to replace the pump package, the pump flow control subassembly is what it's called, and see if that doesn't fix the leak. So we did that today as well. That all went very successfully. We inspected everything we could. We took a lot of pictures, so it'll be good to bring those. Jackie's going to take a little time and walk through the more details of the EVA today, and I'll hand it over to her.
Thank you, Ed. Today we did US EVA 21. It was a 5.5-hour EVA. We started by egressing the airlock. We're about 45 minutes down on the timeline when we began the EVA. Throughout the course of the EVA, the crew members were very efficient in going through our procedures and getting the job done to bring us to about an hour ahead when we decided to bring the pump back up while the crew members were outside. I am going to cue up a video, and I can talk you through the video of what you're seeing at this time. Okay, here we are on the truss, and EV1 Chris Cassidy is removing the PFCS from the IEA from the truss. As he drives the bolt, the box is backing itself off of the truss, and you'll see in a minute as it becomes free.
I see the box rising, indicator moving, 10 turns, 11 turns, running torque ease up.
So the box became free, and he's going to hold it up and present it to EV2 to take some photographs and do an inspection on the backside of the failed box to see if we could determine anything that was wrong with it.
Okay, copy. No flakes. That's good information.
Here you see the crew member, Tom, doing the inspection of the backside of the box, taking lots of photographs for our engineering team to look at later.
We're, looking good for the procedure.
Hey Mike, tag me up please on the big picture.
Next you see them both working on the IEA itself, and they're going to translate to get the spare PFCS in just a moment. Throughout the course of their EVA, they kept looking for any ice or any signs of the leak, and we did not see any during today's EVA. You see EV1 again removing the bolts to get the spare box out so we can put it into the flow location. And this went very easily due to the fact that we did a similar type of box last summer on EVAs 18 and 19, and we learned a lot from those EVAs, and it enabled us to be very smooth in our operations today.
H3 torque broken.
And EV1 is using the ratchet wrench. Now we've jumped to installing the spare box into the truss. And now he is driving the fluid connectors that are on the underside of the box to get the flow back open. This is the failed box. We're again doing one final inspection before we put it back into where we retrieve the spare from, and making sure the work site is safe from debris or any other items that the crew can find, any ice, and making sure we don't leave any tethers or tools outside. And that's all the video I have for you now. So again, it was a 5.5-hour EVA. Very successful. We accomplished everything we went out to do, and even some extra items. Okay?
Thanks very much. We'll start out with questions here at the Johnson Space Center in Houston, Texas, and then we'll move on to questions from the phone bridge. Robert?
Hi, Robert Perlman with collectspace.com. First, how surprising was it that you did not see any sign of ammonia during the walk? Were you expecting that there at least be some residual if the pump was the culprit?
Well, we were certainly prepared to find ice in a variety of locations. So yesterday, a lot of time was spent in two different types of meetings, a crib sheet and ammonia decontamination types of meetings, just to walk through all the scenarios of if there were ammonia, either from the leak itself on various parts of the truss, and then what happens if we pull the box out and find crystallized ammonia or sheets of it underneath. And so we spent a lot of time preparing for and anticipating that there would be ammonia at least somewhere on the truss itself. At the same time, we were trying to determine what we actually thought would happen. So we were prepared for that worst case, make sure we're ready, but prepared for more and had a lot of tools in our disposal in case we came across it. But I think we expected a little bit more than we saw.
And if this does turn out to be the repair, if this is the fix, is there any need or desire to go back out to that area and reverse the work that was done by Sunny and Aki to isolate that radiator?
I think the first thing that's got to happen is for the engineers to look at this over the long term, which is going to be weeks or months really, to get a firm handle on the system. And the reason we keep using that term is because of ammonia is very it changes the way its state, its pressures very easily in the thermal environments, and so as the sun moves through its beta angle, that also affects the telemetry we see in the system. So we really need to get a lot of data to make sure that it's fully stabilized. Once we have a handle on that, then we can look at the things like the amount of ammonia that we have in the system and also the configuration of the system. The configuration we have now, we call it a hybrid situation because we're using the older radiator from the early TCS system. But we've come to know how it operates, and we've come to get comfortable with it. So we're not at the point where we must back out of that configuration. We're also not at the point where we must immediately go out and refill the loop. Of course, we did lose ammonia in all of this, and so as part of the engineering assessment, they're going to look at our ammonia levels and determine, it may not be in the next series of EVAs that we have to do refill. It may be sometime in the future, but that's all forward work. So all of that to say, we don't know yet. Thanks.
All right, that's all the questions here in Houston for right now. So we'll go to our phone bridge. We'll start off and go in order with Mark Carreau at Aviation Week.
Thank you. My question's for Joel or Ed. I wonder if you might be able to sort of characterize the appraisal or troubleshooting ahead to sort of determine whether you've got a repair or not. And could you also talk about the power channel that you took down to sort of deal with the initial stages of this? Does it remain down, or will it be added back, or is that to be determined? Thank you.
All right, well, I'll start, and Ed could finish. I will tell you the power configuration that we're in now, the power down, so no loads on that channel. That's the configuration we'll stay in through the Soyuz undocking and landing tomorrow. After that, we'll start looking at the systems of when we're going to go ahead and power that up. As far as troubleshooting, it's going to take the teams a few weeks to go ahead and just watch the system, understand the system, see how it's performing, look at the different day and night cycles, and again, just watch it over time before they're ready to tell us that we were 100% successful. I mean, it's when you see the snowflakes like we did the last couple of days, it's easy to tell that we have a problem. But we've had that leak in that system for some time now, and you didn't see a snowflakes, but our guys were able to monitor that and watch that, and that's what they'll be doing for the next few weeks. And I don't know, Ed, if you want to add anything.
I'll just talk a little bit more about the power configuration. The power system on the space station is very robust in the way in which we can interconnect the components of it. So right now, of course, we have 8 power channels. One of them is called 2B or 2 Bravo. That's the one with the leaking system that we repaired today, and that's the power channel that has been turned off. The sibling to that is the 2A channel or 2 alpha channel, and what we've done is we've interconnected those 2 channels. So the solar array that provides power to the 2A channel is actually now providing power to both 2A and 2B, and we can do everything we need to do in that configuration for quite some time. It's a capability that the space station was designed for, and we've put those cross connects in place. We've got the power situation analyzed, and we're ready for the Soyuz undocking, for example. And if you remember back in the fall when we had the EVAs to replace the main bus switching unit, we actually had at one point we were having 3 of our 8 power channels turned off, and we were still able to do all the objectives we needed to do at that time. So we've got a robust power configuration. Right now, with the new pump up and running, what that's doing for us is it is providing cooling to the P6 truss components. That includes the batteries that are out there. So we are charging the batteries themselves off of the 2B solar array, and that allows us to start to gain insight into the functionality of that system, and we can put heat loads into it, and again, like Joel was saying, start to characterize the system as a standalone system, And once we get past the undocking and the critical operations in the near term, and the engineers have time to look at things, we'll start talking about separating the power channels and having 2B support its own loads.
Anything else, Mark?
No, thank you very much.
Okay, we'll move on to